So, who are we?
So my name is Damon Smith. I work as a security engineer with iSEC Partners, or NCC Group. My primary areas of focus are web app testing and embedded devices. I've recently started looking at file formats with this guy.
And this guy is Damon Crowley. I also work for iSEC Partners as a security engineer, and mostly I like web applications, crypto, and physical security, but as of late I've had an interest in looking into different file formats and playing around with them. So what's this talk about? This talk is about files that trigger outbound traffic when they're open. And there's a couple of restrictions on that. Obviously, it's not terribly interesting if you take some executable format like PE and say, oh, hey, I can make outbound requests. It's like, well, yes, obviously. So some of these formats are rather complex. So we talked about PDF, for instance, which is an intensely complex format. But there are some very simple formats as well, and we'll get into that a little bit later. But the important thing is we're not using exploits. These are all based on features. These are all things based on how the file formats are structured, how they actually work. These are intended functionalities.
So why does this research matter? There's really three overarching themes as to what makes this so impactful. The first and the most obvious at first glance is privacy implications. Things like de-anonymization or potential use of dystopic DRM in the future.
Take that one off. Turn that on. There you go.
Hello? 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 I can just yell. Does that work?
Try this one.
Is this better? All right, there we go. Everyone can hear me. Excellent. So, gone over some of the privacy implications, and we're going to get into these a little bit more deeply further on in the talk. The next overarching theme to why this is important are the security implications. Specifically, some of these outbound references can do things like automatically sending your credentials to the attacker. So we're going to go and demonstrate that here in just a little bit. Finally, and in my mind most importantly, none of these are bugs. None of these are a mistake that a programmer made when he was writing a parser. These are all things that were intentionally included in the file format specification and intentionally included in the parsers.
So we're going to do a quick demo with a couple of different formats here. So we've got, whoa, hey there. Okay, not exactly what I wanted to do. Still not what I wanted to do. Magical and revolutionary. Okay, so let me get my capture started here. So what I've got running here is an SMB capture through Metasploit. So this is basically just going to receive any attempted SMB communication, ask for NTLM, these mics, ask for NTLM creds, and then capture the resulting communication. So the first thing I've got here is an RTF file. So I'm going to pop that sucker open, and okay, so we've got some SMB, we've got some NTLM hashes coming in here.
And note that there was no user interaction there. So he opens the file and he immediately sends out credentials.
Right. So this will try to connect for a while, and it's really funny after a couple seconds of trying, like a bunch of attempts to negotiate, it gives up and says, okay, well clearly I'm not able to negotiate, and then it says, like, hey, warning, this document contains links to other files. Do you want to like link to those or not? Like, do you want us to get that? It's kind of like, hey mom, can I have that candy that was on the table? Like, no, you can't. Oh, well, sorry. Because here are the hashes.
Cat's out of the bag.
So this one is really, really interesting. So in just a moment, I'm going to show you like why the whole hash thing is important in case you're unaware. But first, I just want to show you a soothing video that's in no way harmful of some very adorable animals. So As it turns out, well, we'll explain why this works momentarily. This is actually a two-stage thing here, but again, here we are getting hashes. And as mentioned previously, these are all based on file format features. These are not bugs. We're not exploiting, well, in a way we're exploiting things, but we're not exploiting any bugs, right? So now that we have all this wonderful stuff going on, I'm going to take the captured hashes here and crack. And I set it up with a really easy password, but here I now have the plain text credentials for the VM that opened these files. So all of this without any bugs, right? We didn't fuzz anything. So let me come back here and then we'll start to break down what happened. So this is not like a super new thing, right? The whole NTLM hash capture and crack, it's not a fantastically new thing, but it's a more widespread thing than I think people are aware of. And there's also a privacy aspect to it that has not been discussed. So there's already some things that are known to allow for this. Office formats, PLS format playlist files, LNK files, you know, there are a bunch of different things. The sort of the state-of-the-art tool in this sort of attack is called Zach Attack, which comes from Zach Faisal, a former colleague of ours, and now works for Urbane Security. But we also noticed from some other sources as we were sort of doing introductory research on this that if you just take like an image tag in HTML and do like source equals some SMB URL, it will trigger this interaction in IE. So if you're using Internet Explorer, even like the latest versions, all it takes is visiting a web page to trigger this kind of interaction. And similarly, Outlook uses either the same parsing engine or one that will respect the same image source equals file URI. So you can get this to happen just by sending an email to somebody using Outlook.
So beginning our research, there are a few areas that we wanted to focus on. We wanted to develop some proof of concept files that would be immediately applicable to the average social engineer. The idea being, we wanted to focus on file formats that are commonly exchanged via email or downloaded from peer-to-peer file sharing networks or downloaded from the web without much regard to security. For instance, document formats. People in an enterprise setting are used to tossing these things back and forth through email all day long. You know, you get a PDF from a coworker, you just open it. As security professionals, we're probably all acutely aware of the problems with the PDF format and memory corruption and stuff, but this is, you know, the average user is not going to be aware of this, especially considering that this is not going to be a thing that's caught by like antivirus or anything, because these aren't memory corruption bugs. Additionally, we focused on media formats like audio, video, and graphic formats. These are kind of things that you could see being shopped around on peer-to-peer file sharing or posted on a wiki, for instance. Finally, we looked at groupware related functionality like enterprise calendaring software and enterprise address book software.
So one of the media formats, we tried to do some research around like, you know, Googling for different file types to see like what's the largest number of hits we can find, you know, looking through our email backlogs to see like what files have we emailed and been emailed the most, all that sort of thing. And one of the ones that just kept popping up at the top of the list for like every single metric we used for like what files should we actually take a look at was PDF. And we didn't see a public proof of concept for PDF, but it's a very active format, so we figured this has to have something that we can use. And as it turns out, it has several things. So the first one, you can embed a remote image. When you specify an image in a PDF document, it can link out to a remote image at some URL. Now this is only supported by Adobe Acrobat and other Adobe PDF parsers. It seems to be in general that PDF functionality is a bit lacking versus, you know, the specification with everything but Adobe products. It makes a certain amount of sense because the PDF spec is huge. So the problem with this, at least from our perspective as attackers, is the idea is that you can't embed file URLs, you can't embed UNC paths, which are just pointing to SMB shares. So you can't do the NTLM capture or relay, but you can track where a document has been opened. So if I generate a version of, let's say that I'm doing like a limited press release or some sort of document sharing with business partners, and I want to see if anybody's taking those documents and giving them out to somebody else who shouldn't have them, I can take a PDF and make several different versions of it that embed a different image from a server that I control and distribute them, and then I can see where that's been shared, but I can't grab hashes through this method. There's also the ability to open a media player, like a video player within a PDF. Weird, right? The PDF. This will trigger a warning that says, hey, and actually it will warn you before it reaches out, unlike WordPad. So it warns you, and then if you say, yeah, this is fine, it'll reach out. And then also the get URL method, which is just basically pops open a browser window with the URL, can also be used to get this to happen. One interesting thing that Damon found was that if you use the long UNC form, something very funny happens. The way that Adobe Reader parses UNC paths is it says, okay, this starts with //, and then it's got the server name, and then a backslash in the path. So this thing after the first 2 slashes and the third is the domain name or the IP or whatever. So it pops up with whatever that is. Now there's an alternative form of UNC called long UNC, which begins with // !// and then the domain name. And so it's a little bit hard to see. Let me zoom in. I think I can do that. Oh, that's ugly. All right, so that's a little bit tough, but you can see it says this document is trying to connect to, So I thought that was really funny.
All right, so the next one, and the one that you are already seen demonstrated, is RTF. And the fun thing about this proof of concept is that it applies not only to Microsoft Word, but also to WordPad. So this is going to pop on any Windows installation out there. Specifically, the technique for getting this one was a linked document. It's possible to embed a link to a file in an RTF. For instance, if you want to include a picture in your RTF file, but instead of actually including the contents of the picture, you want to include a link to it so that it's updated, and every time someone opens the RTF, they automatically get the latest version. This can obviously be abused, and the way that we were able to achieve this is by linking to a Word document that's hosted on a remote UNC path. So every time they open that RTF, it goes out to that UNC path and tries to download the latest version of the Word file. This one, as you already saw, is pretty funny because while it does issue a warning, it's completely ignored, or the warning is a bit too late, right? So your input, there's no way to stop this. If you open this file, you sent me your credentials, end of story. The next one that we got, we wanted to get some graphics format. So I don't know if anyone's familiar with the SVG file format. It stands for Scalable Vector Graphics. It's slightly different than the traditional graphics format in that it is a format for exchanging vector-based graphics instead of bitmap. So in a traditional bitmap image, you basically just have a bunch of bits that correspond to pixels and what color they are, and it describes the image. In a vector format, you have mathematical equations that describe lines and the slope of the line and things like that in order to draw a picture. The fun thing about SVG file is it's basically a subset of HTML. It implements a lot of the same tags that you can find in an HTML document. For instance, image source is totally valid, even including JavaScript. Why would you want to include JavaScript in an image file? I don't know, but I didn't write the format. So the way that we were able to get this one to do NTLM auto-authentication was via remote style sheets. Just like you can in HTML, you can specify the location of a style sheet for the SVG document. You put that as a UNC path, and bam, got your credentials. And by default, these are parsed with Internet Explorer on Windows as well. So that's also interesting.
So these were an easy win. We knew that the PLS format already was known to enable us to do this kind of attack. So we took a look at some other formats, other playlist formats, M3U and ASX specifically. So M3U is an incredibly simple format. It's just a list of resource paths, and those resource paths can be absolute paths, relative paths, or a URL, which is interesting in our case. In the case of M3U, PLS, and ASX, all of these allow for, on Windows anyway, allow for UNC paths, so we can easily get the NTLM thing triggered. So MP3 looked promising when we started looking into it. MP3 by itself is a very simple format. It's just something like 16 or 32 bytes of data about the of metadata for the next 16 bytes, which are just the raw audio data. So it's just back and forth, back and forth, back and forth with these. But because it's such a primitive format that's focused entirely on the audio, there's no room for anything. Now, this might sound confusing because you're like, well, what about ID3? Like, well, actually, that's not a part of the MP3 format. It's just something that media players all of a sudden decided, like, well, this doesn't have any metadata whatsoever, so let's start like just including this ID3 format at the top of it. So ID3 has just a bunch of frames. There's the link frame and the APIC frame are the ones that we're interested in, because the link frame basically says there's supposed to be a frame here, but this isn't the frame you're looking for. The frame you're looking for is in that castle over there. In that castle is an attacker-controlled server, right? And the APIC frame is attached picture. So you have some picture that represents a cover or album art or something like that, and you can either have it embedded in the image or you can link off to some URL. Interestingly, so you might be wondering why I have a brightly colored fish as a picture. So as it turns out, while I was reviewing the ID3 spec, one of the enum values for what type of picture it is, because like let's say like 11 is the cover image. I believe it's number 13 is a bright colored fish. So thank you, little snitch. Party time. Great. So anyway, bright colored fish. Interestingly, Primus is also enumerated as a genre in ID3, which I mean I'm kind of in support of. But anyway, the unfortunate thing about this is that neither of these features of ID3 tagging was supported on any major player we tested. So this, while it should work, was kind of a bust.
All right, so continuing in the realm of multimedia formats, the next one we found that we got a quick one on was the ASF family of formats. This includes Windows Media Audio and Windows Media Video. You saw this demonstrated just a little bit ago with a very innocent video of wildlife that pops open an Internet Explorer page and gets your NTLM credential sent to an attacker. So the way that we achieved it in this proof of concept is what's called script commands. It's possible to embed script commands in a Windows Media Video or audio file that at a certain time in the video, the player will execute these script commands. There are a variety of commands available, but the most interesting one for our purposes was this one called URL and exit, which means open this URL, parse it however you would normally. So if it's an HTTP URL, it's going to open it in your browser, and then stop playing the video. The implications of this one are fairly obvious. As far as tracking goes, you put this in a video file, throw it out on peer-to-peer network, and bam, anyone that opens this is now informing your server that they've opened this video or audio file. Additionally, one of the limitations of URL and exit is that it's not completely transparent. You saw the browser window open, so you're going to tip your hand to anyone that opens this video file that they have been tracked. One area of future research that we're hoping to get to real soon is DRM functionality of use. The idea being it's possible to apply DRM to a Windows Media video file, which basically encrypts the entire contents of the video and specifies a URL where the player can go to get the decryption key. That's how DRM is implemented at a high level in the ASF family of formats. The obvious abuse there is that we can specify our own URL, and as soon as you start viewing the video file, completely transparent to the user, it visits our server to download the decryption key, and then we've tracked you. Finally, there's one other interesting vector here, and that's subtitles. Subtitles in the ASF format are basically just raw HTML, generally used for including text. Alternately, you can do things like change the color of the text. For some reason, you can actually embed an image, so you can do image source equals in a subtitle, and it will straight up go download the image and display it at the bottom of the video like it was a subtitle. That's completely insane, and no one would ever have legitimate reason to use it that I can think of, but it works, and it allows us to get NTLM credentials. The caveat here is they have to explicitly say, I want to see subtitles. They're not enabled by default.
So maybe you distribute a foreign film, and, So one interesting note about the URL and exit technique, you can't actually give a file URL or a UNC path in the URL. It'll refuse to launch that. However, if you give it an HTTP URL and it hits that, so let me, we've got limited time. I won't show you, but if you redirect from that HTTP endpoint to a file URI, it'll happily bounce to that and provide NTLM negotiation. But so you have to have that intermediary step. So torrent was one we looked at. Unfortunately, we couldn't find any parser that would accept file URIs or UNC paths for any of the things that we took a look at inside the torrent format. So, but what we did think about was, well, we can provide an arbitrary number of URLs in the announce list, so it'll check out all these trackers. It'll hit all of these URLs as soon as you try to start torrenting whatever this torrent is supposedly for. So we thought, well, why not do something else with this? Why not take all the CSRF flaws in home routers that we can find and just try mass exploitation of all these different flaws. So you pop open this torrent and it tries to exploit your router in a number of different ways, and then after all of that exploitation attempt, after every exploitation attempt has gone through, it then finds the real trackers and starts downloading. So it can be a completely functional torrent that just happens to own your home router first. So, thought that was interesting.
All right, so the next one we got a quick one on was the virtual card format. It's used for exchanging virtual business cards, basically address book entries. Very common in enterprise environments to send these things around. So this one is a little bit trickier. There are some real caveats to this one that make it very difficult to exploit, and it would require some social engineering pretexting to get it done just right. The vCard format, as one of the fields that it supports what's called a free busy URL. This is usually a web server that your email client can ask, at what time is this person in my address book available for a meeting? It's a really handy feature. For some reason, we found out that it actually supports file URIs. Obviously, that doesn't really make any sense, and I can't understand why they would program it that way, but whatever. My free busy URL, if you want to know when I'm free for a meeting, is //attacker.com, and it'll send me your NTLM creds. So the one caveat here is that I would have to get you to add me to your address book and then say, hey, let's schedule a meeting, and then you'll have the exploit delivered. So it is a little bit of a caveat, but it's still a very interesting find.
So on the topic of groupware stuff, there's the iCalendar format, or ICS. So this is generally what you get when you send or receive a meeting invite. This is the format that's being used most of the time. So this is another one where we had high hopes for it when we were reading the specifications, but again, file parser, implementations of file parsers, and the specification that says, here's what you should do, there's some difference there. And in this case, it's actually really good, and you'll understand why I say that when I describe this to you. So there's the valarm parameter, which can be included as a part of an ICS file, which is actually an embedded reminder. So when you send a meeting invite and you have some reminder set, that's actually in the meeting invite. So now you know why reminders that you didn't set show up. It's because they're in the meeting invites. The spec defines 4 different types. The first is display, which is pop up a pop-up. The second is alarm, which is do some default sound. The third is audio, which is play a sound from the machine or go fetch a sound at a particular URL and then play that. And the fourth, which is really funny, is procedure, which is the same thing as audio, but with running a program. So it's okay, yeah, go to this URL, download this program, and run it at a time when I specify in my meeting invite. What? What? Thankfully, and sadly for our purposes, This doesn't work in any calendar user agent we've tested, even iCalendar, well, calendar.app, which is the successor to iCalendar, which is great. Like, you can make, I could get into it, but it doesn't work, even in the successor to iCalendar, so that's funny.
So you might be thinking, okay, how can I apply this today? The most obvious method is to use it in a part of a social engineering engagement. Send it to someone over email, have them open the file, you've got NTLM credentials, and you can just rain shells down on them. Additionally, just name it Employee Pay Raises 2015 and fire it off of every open file share you find on an internal network. Guarantee that people are going to be opening that file within like 5 minutes, and you're going to start getting some creds. Yes?
Sorry, there's something I don't understand. I understand that the person receiving the URL will click on it and then they will be tracked. But how will they send you their NTLM?
Sure. So I understand that that's a little bit confusing, and the idea is basically it revolves around the file URI in Windows and how it's parsed. If I send you a URI that says file : and then an IP address or a host name, what your Windows computer will automatically, transparently to you, what it will try to do is assume that that remote host is an SMB or Windows file sharing server, and it will try to authenticate with that remote server so that it can download the file that you want. Unfortunately for you, that remote server happens to be my server, and you just sent me your credentials, or at least a hashed version of your password. As you saw, we cracked that very quickly earlier.
Yeah, Windows will automatically attempt to negotiate to authenticate using your credentials as the logged in user.
Yeah.
So whatever user you're logged in as, it's going to try to authenticate automatically, so you don't have to put in your username and password again, which is a very handy feature. Thank you.
So that only applies to Windows?
Yes.
Yes.
All of the NTLM credential capture attacks are Windows specific. The tracking stuff can be used on any operating system, but the authentication stealing stuff is really Windows specific. Yep. So back to delivery methods. Watering hole attack, you throw this on an internal like SharePoint or something, and people will start downloading it and opening it. Peer-to-peer distribution. This one is very interesting. One of the possible, I guess you could call it more ethical or more appropriate applications we thought of for this technique was doing something like catching child pornographers. So you throw some, smut video on a peer-to-peer file sharing network, and you embed tracking code in it. Hopefully you'll be able to catch yourself some bad guys that way. Finally, we considered using this as sort of a honeypot. So you put this tracking code in all of your internal documents that you want to keep a secret, your corporate memos, your financial stuff, your HR stuff, whatever. And if this is ever opened outside of your organization, you're immediately notified.
Or just have one document that purports to have something juicy in it, but doesn't actually contain anything. It just contains like a bug that says, "Hey, I've been opened." So if that ever goes off, rather than having this huge noise about like, okay, well this document was opened and this document was opened and this document was opened, you can have just one file that says, "Hey, I should never be opened. Guess what? I'm open. Look at who's opening me." So one way that this could be used, unfortunately, would be for DRM. So as Damon mentioned, the child pornography, the law enforcement aspect of it. This same sort of technique could also be used for, let's say, copyrighted music or movies. So you distribute your copyrighted work in WMA format, and every time it gets opened, somebody knows about it, probably at the RIAA. It might already do this in some cases. As we mentioned, there is DRM functionality in the Windows Media Format family, it's probably by somebody out there already being used in this way. And this goes beyond deterrence into identification, because all of a sudden you have the IP addresses of the people, and you can start identifying them, even if they've not downloaded it from something you control or can monitor, like BitTorrent.
All right, so the next application we were thinking of, and I'm going to run through these pretty quick because we're running out of time, a data loss prevention scheme. So imagine being a whistleblower in a fascist country, or a country that isn't supportive of whistleblowers. I'm not going to name any names. So you exfiltrate a document that exposes, let's say, military abuses of power. Unfortunately, every time this document is opened, it calls home. So first it calls home from your work computer. That's expected, nobody comes after you. Then it calls home from your home computer. Then it calls home from your friend's home computer, and then your lawyer's computer, and then your journalist's computer, and then you all disappear.
Right. So definitely an interesting thing to think about. Another interesting thing to think about, if you've ever used Tor browser and you've downloaded some file that can't open through Tor browser itself, you'll see a warning that says, hey, we can't proxy external applications. If you open this from this in an external application, it might unmask you. Well, this is the kind of stuff that they're talking about in that warning. So this is exactly what that warning is about. So if you download, let's say, how to make a gas mask for the protest you're going to, .pdf, and open that outside of Tor browser, it might unmask you. Pun not intended. So, or on the flip side, let's say that you want to identify internet jihadis. You might be able to upload like how to make a bomb in 3 easy steps.pdf to jihad is great and cool and stuff.com, and then identify who's looking to make a bomb in 3 easy steps.
All right, so we've already demonstrated this technique, and we've already gone over a bit of detail, so I'll go over this pretty quickly. Basically, when you attempt to authenticate, when you attempt to open a file on a UNC share, Windows will automatically authenticate. There's a lot of different things that the attacker can do upon receiving this authentication information. One is just to straight up crack it like we did in our demonstration, but another powerful method, let's say you have a strong password that isn't easily cracked, you're still not safe. We can employ a technique called NTLM relaying to use your hash without actually knowing what the plain text value of your password is. And Dan's going to go over how this attack works.
So basically, the normal, at a very high level, normal NTLM negotiation works like this, at least in version 2. Client says, hey, I want to connect. Server says, okay, well, you got to authenticate. Here's a number to mix in with your hash. So client mixes that in and sends that information back to the server, which verifies it and says yes or good or no access denied. Now, let's say that we can get a client to attempt to authenticate to us. There's no information in that exchange which ties it to that particular conversation. Well, it ties it to that particular conversation, but it doesn't tie it to that particular set of interacting hosts. So client negotiates to us, we negotiate to the server gives us a challenge which we pass back to the client correctly mixes that challenge in with the appropriate hash, and we can send that straight along to the server and then tell the client, sorry, that didn't work, try again. So as long as the client, and you saw in the listing of the SMB capture how many times it tried to authenticate. For every time it tries to authenticate, we can pass that authentication on to a different server by starting a new conversation with some other NTLM protected host. Doesn't matter if it's HTTP, SMB, whatever, we can pass that along. So it doesn't matter if your password is strong, we don't actually have to crack it, we can just pass it along to something else, like Outlook Web Access or some such thing.
Or a domain controller.
Or a domain controller.
So another potential attack scenario that we've investigated with this research is delivering cross-site request forgery payloads. The most obvious one, like we said, is the one torrent file to rule them all. You start downloading it, it pops every known public exploit on routers, and then it finally downloads your torrent file, but it's already completely owned your router. Additionally to owning routers, there are a lot of other things you can do. Generally, the inside of a corporate network is a nice, soft, squishy target. So if you can get someone to download your hostile torrent file or your hostile PDF or whatever, you can embed cross-site request forgery payloads in that document that as soon as it's open, will deliver against the internal corporate network.
So we thought a little bit about possible mitigations, and we haven't got anything that's a silver bullet against this, but we've got some good ideas. So we're going to just briefly discuss what we thought about and whether or not we think it's worth anything. So AV, probably not. There's way too many file formats out there. Part of the point of this research was to show that there's a wide range of different formats where this kind of attack can work. There's also the possibility of false positives. I mean, these are all features. Like, these are all things that people might use for legitimate purposes. And so it would be hard to distinguish between a legitimate use of some feature and an illegitimate one. Changes to the formats, there's too many of them out there, and they're too well established in a lot of cases to go changing the formats now. You know, it's not really easy to make a change to programs that are being used in the wild. It's even harder to make like structural level changes to formats that multiple different programs are using. We took a look at application level firewalls like Zone Alarm, like Little Snitch or Leopard Flower. These are all wonderful tools, and they help a lot, because if you think, well, I don't ever want my PDF to be reaching out to the internet, okay, just use your application level firewall to say Adobe Acrobat should never be able to connect to anything except like adobeupdate.com or something like that. So that's easy for something like a document format, which should never ever, you know, for some use cases, should never ever be communicating with the internet. It's harder for something like M3U, where, you know, you download some playlist and maybe you listen to internet radio, and you can't really make those hard and fast rules, so you're gonna have to do it on a more granular basis. So, go ahead.
A few other possible mitigations that we considered. The most obvious one is warnings. We already know, there's a little snitch.
Yeah.
We know that users are, anyways, we know that users are very bad about just clicking yes on any warning dialog box or whatever gets into the content the fastest. So warnings might help for a properly educated and trained user, but they're not a general panacea solution. Finally, we considered developing a tool that you could use as sort of a network level sandbox for opening these files. Basically, if you're familiar with how proxy chains works, it basically hooks the networking functionality for an application and directs it all through a proxy. We could do something similar to that by hooking all of the network functionality for an application and just dropping it. Like PDF reader, you should probably not have network functionality for the vast majority of cases, so we're just going to kill it. In addition to stopping these tracking attacks, it could also be used to notify you of bugs in files, so you can do one step beyond and say, oh wow, this file has a bug in it, I should probably tell everyone that might be interested in using this file. Finally, egress filtering. Realistically, your corporate network should already be doing this, and you should not be allowing NTLM traffic, or you should not be allowing SMB traffic outbound, right? You should be blocking that at the perimeter. Unfortunately, there are still some concerns around this. It might stop some legitimate connections. There might be legitimate use cases for connecting SMB traffic outbound in some enterprise scenarios. Additionally, it's not going to stop if the attacker already has some sort of foothold on your internal network. You know, you can't just assume that they're not going to be inside your perimeter, so this is a good mitigation, but it's not a panacea.
So I think we have about 1 minute, 2 minutes maybe left for questions. So do we have any questions in the audience? That looks like that's
either did a really good job or a really bad job.
Did you test primarily Windows-based parsers for these, or did you look at Linux as well? In other words, you know, for something that might process RTF or MP3, I wonder if the features are the same, independent of the implementation.
So for some formats, it's going to work the same everywhere. So for instance, M3U, it's going to work because that's a necessary part of the file format.
The tracking for PDF would work as well.
Yes. You know, as long as you're using a PDF reader that supports those features. We found that the support for the remote image thing, for instance, is not very good. The support for the JavaScript is a little bit better, but still not wonderful. Mostly we tested Windows-based file parsers, just because the security implications were particularly interesting there. But I can tell you that a lot of these will work on Linux and OS X systems as well.
Did you guys try doing this like SMB stealing on different ports, or does this only work on 445? Or?
So that's actually very interesting, and it's an area of the research that we didn't really, we didn't get as far as I'd like to, but basically there's an interesting sort of nuance to how Windows negotiates these SMB connections. It will try to connect over port 445, I think, first, and if that fails, after I think like 10 seconds, it will try to fall back to web dev, assuming that the remote server, oh, it's not an SMB server, it must be a web dev server. We haven't yet gotten a working proof of concept that will steal the authentication credentials via web dev, but if we can get that nailed down, and I think we're probably going to be taking another look at that,
We
that
need
could
some steps.
that could really expand the impact of this research, because it's no longer a port 445 issue, it's a port 80 issue.
Right.
And if your egress firewall is blocking port 80, then you're on a very secure network, and you're probably not the subject of this attack anyway.
445 is commonly blocked, so I
Yeah.
just wonder like what
Right.
other avenues you might be able to.
So one interesting thing, you can, so Windows will automatically authenticate for SMB just wherever it is, right, by default. For web traffic, if it requests NTLM authentication, if and only if the domain name does not have a dot in it, or if it's an IP address, if it's not within the reserved private IP ranges, it will if it's within like private IP ranges or on the local network by a domain name that doesn't have a dot in it, it will automatically do that authentication even for web-based stuff. But yeah, you're right that egress firewalls usually prevent 445 if they're in place. So.
Do egress filtering. All of you that run networks, please do it.
Yes.
Any other questions?
All right, I think that's it.
Thanks very much for your attention.